right, let me move back to the first. Got a few slides here. And then let me pull up. All right, so there, oh, let me add it to our. All right, so the unit circle, and let me go turn some lights off in here. You people at home should be able to, no, y'all can't see it because I hadn't shared my screen. There, y'all can see it here. Let me share my screen. Share screen. All right, so there is the unit circle for you people at home to see. We'll be pulling off things off of that. Remember, the sign as we go around is the y coordinates, the cosine is the x coordinates, and then I've got the tangent sort of written out where we went ahead and simplified those because they're sine over cosine. But here is what, where is that? Basically what we're going to be doing. Now, let me go back to that unit circle and let's look at it real quick again, if I can find it, what I did with it. There it is. All right, so remember, as we go around, like if I'm looking at my sines, all right, where the sine value of whatever equals 1/2, well, it's at pi over 6. But there's going to be another spot on here, too, that equals 1/2, the sine equals that 1/2. Basically, within the 360 degrees, most of these are going to be the same in two different spots. So for 30 degrees and 300 degrees, both of those are sines of 1/2. All right. Notice sine equals 1 only in one spot. So there are certain spots that within the unit circle, it only happens once. Sine equals 1 only at 90 degrees. But also remember, one time around is 360 degrees, but as we're going to, most of the time we're going to be looking at radians. Radians is 2 pi, is one full circle. A half a circle, 180 degrees is pi. All right, because remember, if 30 degrees, the sine of 30 degrees is 1/2. If I go a complete another rotation, which would be at 390 degrees, that its sine again is 1/2. So at some point we've got to account for all these every time I go all the way around. So basically every time I add 2 pi, okay, I'm getting back to the same point. All right, so we'll talk about that in a moment. But here's what it's going to be looking at. Basically, we're solving these equations. What is solving equation? Solving an equation basically means what value of x makes this true. So we're looking at angle measurements that would make this true. All right. Notice the secant, 3 secant x minus 6 equals 0. Okay. And they're asking us now, they're just asking us to verify if these are true. So we could use a calculator and put it in radians mode. All right. But here's what we're going to do with that to verify that it is. So if I can get this to work. So I've got 3 secant of x minus 6 equals 0. Now, I'm going to use the unit circle. On the unit circle, we just have sine, cosine, and tangent. But what we do know based on our identities and stuff is sine is equal to 1 over cosecant. Cosine is equal to 1 over secant. So this is a secant. So what I'm thinking is I might be able to use cosine somewhere in here, because then I can look at my unit circle on my cosine. So notice what happens. If I want to solve for x, just like anything else, I've got to get the secant of x by itself. So I'm going to add 6, and I'm going to get 3 secant of x equals 6. And then I'm going to divide both sides by 3, and I get secant of x equals 2. Now, there's nowhere on my unit circle that tells me anything about secant. But I know secant is the same thing as 1 over cosine. So I can replace secant of x with 1 over cosine of x equals 2. Now, if I solve this for the cosine of x, right, what would I do? I'd multiply both sides by cosine of x. So I get 1 equals 2 cosine of x. And then I'll divide by 2. And I get cosine of x equals 1/2. Now, here's what's key. All right. What angles that give me the cosine of what angles would equal 1/2? Well, this is where I pull back up my, where is it? My unit circle. At what points on this unit circle does the cosine equal positive 1/2? Remember, cosine is the x coordinates. So if I go around here, where am I equal to my x coordinate equal to 1/2? Look, right there at pi over 3. And if I go back around, that's negative 1/2. I need a positive 1/2. And then all the way back right here at 5 pi over 3. So the 2 points at which the cosine equals 1/2 is at pi over 3 and 5 pi over 3. So if I go back to my, it's wanting me to verify right there. Well, that's it. Pi over 3 and 5 pi over 3 are the 2 answers I'm looking for. All right. So I got to go back and look at how they want us to answer that. Let me pull this back up and see if I can go back to that, see what they're wanting in those boxes. Equals 6. So what they're wanting there is that equals the secant of pi over 3 equals 2. That's what they're looking at there. So I really went through and solved it. What they're wanting actually to get in this one particular, which I looked at a little bit wrong, but this is how we'd work through and solve and find both of these answers. Okay. What they're wanting to know here, and I went a long way about it, is they're wanting to know the secant of pi over 3. Well, here's what would have been easier to do in this particular problem, but I would go to pi over 3. Secant is the inverse of cosine. So the cosine is 1/2. So what's the inverse of 1/2? 2. So basically what we're saying is this is equal to 2. This is going to be 3 times 2 minus 6, which is 6 minus 6, which equals 0. Which for some reason they're saying they want 6 there, but I guess they're saying they're wanting 6 minus 0. Let me look back at that. Sometimes this, oh, there's a minus 6 right there. Yeah, so what they're doing is they're asking you to simplify 3 secant of pi over 3, which is which is 6, and they've got, I cut this off. There's a -6 right here, so that fills in 6 there. And the same thing here, secant of 5 pi over 3 is 2. So this is 3 times 2 minus 6, and there's a -6 there in the problem, so it's 6 minus 6 equals 0. Okay, so this over here is sort of what we're getting into. And that's how you would actually solve this and get the pi over 3 and 5 pi over 3. But verifying here, they just want us to find the secant of pi over 3 and the secant of 5 pi over 3, which the unit circle does not have. So that's why I went, the inverse of secant is cosine. And so when I went to pi over 3, the cosine was 1/2. So that means I've got to flip it around to get the secant of that, which would be 2 over 1, which is 2. So I would check those two right there. That's what's actually what happened right there. All right, so now here there's going to have to be 2 or 3 that's like this. They want to, okay, the cosine of what angles is equal to the negative square root of 2 over 2. So this is just straightforward. There's nothing to solve. It's already solved for the cosine of x. So I'm going to go to my unit circle, and I'm going to find negative square root of 2 over 2 for the cosine, which is the x coordinate, which right here, if you'll notice, is 3 pi over 4. And then the other one is right here at 5 pi over 4, when the cosine is equal to negative square root of 2 over 2. So 3 pi over 4 and 5 pi over 4 is what we're looking for. And 5 pi over 4. And it does say enter your answers from smallest to largest. Now notice, it said only on this interval. So only from 0 to 360, which is what is on that unit circle. Now, if it did not give you this right here, and it just said find all the solutions, well, what we know is 3 pi over 4, the cosine of 3 pi over 4 is equal to negative square root of 2 over 2. But every time you go around that unit circle 360 degrees, it's going to come back to that negative square root of 2 over 2 for the value. So what you have to do is you say plus, and then we're going to put a value of n, and one time all the way around 360 degrees is equal to 2 pi. So what you would see is 2 n pi, and n is just 1 means I would go around once. 2 is you would multiply that by 2, go around twice, 3 times. So basically, this is a way you're saying that every 2 pi times every time you go around 2 pi, you're getting back to this same point. So I would say the same thing right here, 2 n pi, where n, and I think that's explained a little better. Let me see. Right here. Moreover, because sine of x has a period of 2 pi, because it goes around, every time you go around the full circle, you're right back at where you were. There's infinite many solutions, and notice this is what they're saying. They're adding the 2 n pi. The n is just a variable, an integer, so any number you multiplied by 2 pi is going to represent an angle that has that same value. Now, on that particular problem, though, because they told you we're only looking at 0 to 360, we really don't have to worry about that at this point. But be aware that you may have to on some of these others. All right. So now let's look here. Now, look, this one, we're going to have to solve it kind of like we did a minute ago. So what we have is 2 sine of x plus 1 equals 0. Now to solve these, I want to get the sine of x by itself equal to some number. So then I can then go to my unit circle and look at what angles gives me that value of sine. So how would I solve? I would subtract 1, and I would have 2 sine of x equals -1, and then I would divide by 2, and I get sine of x is equal to -1/2. All right, now look, they're telling us to use n as an integer constant. So we're wanting to represent every angle, no matter how many times you go around the unit circle, that is going to equal this. So I'm looking for when is sine of x equal to -1/2. So I go to my unit circle. The sine is the y coordinate. So it's +1/2, -1/2 right there at 2 pi over 3. So 2 pi over 3 is one of mine. And is there another one? There should be another one. 2 pi over 3. I'm looking at -1/2. There's -1/2 again. Nope, I'm looking at the wrong one. -1/2 right there for the y coordinate. That's the sine. That is 7 pi over 6. So 7 pi over 6. So these are the two angles within the 360 degrees that gives me -1/2. Sine of these two angles equals -1/2. And then I have to add 2n pi because every time I go all the way around, it's back to that same angle. So, and I believe if I move that, that's what they're looking for. So, well, I got 7 pi over 6. 11 pi over 6. Let's see if I messed up somewhere. Where's 11 pi over 6? -1. Oh, yeah, that's what I did. Did everybody see what I did right here? I circled that -1/2 right here, and that I flipped over to the x coordinate. I've got to focus. It's a sine, so I got to be careful that I don't flip over to the x coordinate. I'm only looking at the y, where that is a positive. The -1/2 is right there at 7 pi over 6, and the other y coordinate of -1/2 is at 11 pi over 6. So I made a little bit of a mistake there. So this is wrong, and it wants it in order. So my 11 pi over 6 is going to go right here, and then the plus the 2n pi, and this is going to be my 7 pi over 6 plus 2n pi. So be sure, don't make the mistake I just made. I've got to focus in on only the y coordinates. Okay. And what I did is I got around here and I skipped over to the x coordinate, which is easy to do because of all these numbers are repeating each other. All right. All right. Same thing. So this one's sort of stepping you through it. It's telling you to subtract the constant from both sides. So I want the cotangent of x plus 1 equals 0. So basically what they're saying is I'm going to subtract 1 from both sides. And so the cotangent of x is equal to -1. Now, where is the cotangent equal to -1? Now, our unit circle, I don't have listed cotangent, but I have tangent. Remember, tangent and cotangent are inverses. Well, what's the inverse of -1? -1 over 1, you flip it, it's still -1 over 1, right? So anywhere tangent is -1, that means cotangent is also -1. So where is tangent? And I've written it out here. There's tangent. Tangent's undefined. Tangent is -1 at 3 pi over 4. I don't know what's doing. Got too much stuff going on, I guess. My computer's locked up. So that'll be at 3 pi over 4. Is that what we said? And where else is tangent? -1 is down here at 7 pi over 4. So 3 pi over 4 and 7 pi over 4. Now notice, I want you to notice I noticed this when I was looking at these answers. 3 pi over 4 and 7 pi over 4 that's exactly splitting that circle in half, which means they are pi units apart. If I added pi to 3 pi over 4, I would get to here. If I added another pi, I would get back to here. Add a pi again, I'd get back to here. Every time I add pi, I'm getting back to one of these spots that has the tangent equal to -1, which I could say 3 pi over 4 plus 2 pi or 2n pi. That way, every time I came back around to this spot, and then I could list 7 pi over 4, and every time I added 2 pi over that. But I think what they're doing is whenever it's split completely in half, they start with this one, and then they add pi. They put n pi, because every time I add pi, I'm getting back to a point that the cotangent is -1. Now let's see if this has stopped spinning. All right, so the term cotangent of x is now isolated in the equation. Find a particular solution on the interval. Now notice they tell us what solution is on 0 to pi, and the one that was at 0, between 0 and pi, was this 3 pi over 4 is where cotangent equals -1. So 3 pi over 4. All right. On the entire, from negative infinity to infinity, there's an infinite number of solutions. Write the general form of the solution. Now, they said just one form. That's where I got confused earlier. I'm like, well, I would have 3 pi over 4 plus 2n pi, and then I would also have 7 pi over 4. But because they're split in half, what they're wanting you to do is say 3 pi over 4, and then every time you add a pi or you go 180 degrees, we're back to that -1. So that's how they're wanting you to write that. And I believe when I uncover the answers here, that's exactly what they did. Okay. Now, if you actually answered, if this wasn't on the computer and you answered 3 pi over 4 plus 2n pi, and you also answered 7 pi, what was it? 7 pi over 4 is -1. 7 pi over 4 plus 2n pi. This would also be correct, but because they split and they're 180 degrees apart, you can short your answer to just this right here, because every 180 degrees, it's coming back to that -1. All right. All right. Now look at this one. All right, so you got cosine of x times cosine of x minus 1. Now we have to go back to solving polynomials in this zero product property. If you had x, whoops, x times x minus 1 equals 0, how would you solve that? Well, it's factored. What you do is you set each factor equal to 0, and then when I solve that, I get 1. I get two answers. I get x equals 0 and x equals 1. Well, it's the same thing here. I'm saying, okay, the cosine of x could equal 0, or the cosine of x minus 1 could equal 0, which when I solve that, I get the cosine of x equals 1. All right. So I've got two things I've got to look up. What's going to make this true? Well, it's going to be true if the cosine of x equals 0 or if the cosine of x equals 1. So I go to my unit circle. Cosine is the x coordinate. When is the x coordinate 0? Right there at pi over 2 and at 3 pi over 2, which these are split in half, 180 degrees apart. So the way we could list that is pi over 2 plus n pi. Every 180 degrees after that, it's going to go back to where the cosine is 0. Now, when is the cosine equal to 1? Cosine is equal to 1, which is the x coordinate, only right here at 0 degrees. So I would say this x is going to be there at 0. And notice that's it. That's the only 0. It's the only time the x coordinate is 0 is, or I'm sorry, that's the only time that the x coordinate is 1 is at 0. So it has to go all the way around 2 pi every time to get back to there. So what I've got to put is plus every 2 n pi. So for every 2 pi, it gets back to that 0 where the cosine is equal to 1. All right, which I think maybe, let's see, the smaller unit is right there. Notice they just put 2 n pi because what is 2 n pi plus 0? It is 2 n pi. And then right here should be what we had right there. Pi over 2 plus every 180 degrees gets me back to that. So pi over 2 plus n pi. Now, remember, they want you to put the smaller value here and the larger value here. So this one comes from 0 degrees. This comes from 90 degrees. So this one's actually the smaller angle. All right. All right, now, last one. Look at this one. We've got secants and cosecants. And what we need to do is I need to try to simplify this down to something that I can use on my unit circle. All right, which secant is the inverse of what? Cosine. So that I could make that 1 over cosine. This cosecant is the inverse of sine. So that would be 1 over sine, 1 over cosine, 1 over sine. That probably doesn't help me any. But notice this. I could divide both sides by 7, and I would get secant of x. Cosecant of x equals 2 cosecant of x. Now notice this. If I divide both sides by the cosecant of x, that cancels and that cancels, and I'm left with the secant of x equals 2. Now, for my unit circle, I need it as a cosine, right? This is what we did earlier. 1 over secant of x is equal to 1 over cosine of x equals 2. And then when I solve that, that means cosine of x equals a positive 1/2. So what I'm looking for when I go to my unit circle is where is the x coordinate 1/2? Right here at pi over 3. So x equals pi over 3. And let's see, where's the next one? Is this one going to be where it splits in half, or are we going to have to write it 2 different ways? 1/2 was right there at pi over 3. Where else is a positive 1/2 on the x coordinate negative? Right here at 5 pi over 3. So they are not splitting in half. They are not 180 degrees apart. So 5 pi over 3, I'm going to have to also put 5 pi over 3. And then I have to write every time it goes all the way around, there is also an angle at that exact same spot. And actually, notice right there, they say on the interval 0 to 2 pi. So this part is not needed. I just need pi over 3 and let's see if that's what they give us. Pi over 3 and 5 pi over 3. All right, so basically we're just solving down to where we can get sine, cosine, and tangent equal to a number. We go to our unit circle and find out what angles do they equal that, and then that's basically how you solve these trig functions. All right, so I'm going to go ahead and wrap this up, and let me stop the recording.